In this episode, we focus on databases and other sensitive data repositories, because these are often the places where the most valuable information eventually rests, even if the application layer is what users see. A beginner might assume the web application is the main security concern, but attackers frequently aim past the user interface toward the data store, because data is what they can steal, manipulate, or ransom. Hardening means making a system resistant to misuse, compromise, and accidental exposure by applying secure settings, limiting access, and reducing unnecessary features. Doing it thoroughly means you do not stop after one or two obvious steps, like changing a default password, but instead build layered defenses that keep working even when mistakes happen elsewhere. In payment environments, databases can hold transaction records, customer details, and sometimes sensitive account data, so the stakes are high and the evidence expectations are strict. By the end, you should be able to explain what database hardening is, why data repositories are special targets, and how thoughtful layers of access control, configuration discipline, monitoring, and lifecycle management make data stores safer over time. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to start is by clarifying what we mean by a sensitive data repository, because it is broader than a database server. It can be a relational database, a document store, a data warehouse, a file share, an object storage bucket, or an application-specific vault that holds records and artifacts. What makes it sensitive is the type of data inside, the role it plays in business operations, and the impact if someone reads, changes, or deletes it without authorization. Beginners should notice that data repositories often become central points of trust because many systems rely on them, and that centrality makes them high-value targets. If an attacker can gain access to the repository, they can often bypass many application controls and access the information directly. Even if the attacker cannot read everything, the ability to alter data can be just as damaging, such as changing transaction outcomes or corrupting audit trails. Hardening is therefore about preventing direct access, controlling who can do what, and ensuring the repository behaves in a secure, predictable way under stress. The first hardening layer is access control, because the safest database is the one that cannot be reached by unauthorized systems or users. This begins with network-level exposure, meaning the database should not be directly reachable from the internet and should not be broadly reachable from general internal networks either. In segmented environments, only specific application components should be able to connect to the database, and only on the specific ports and protocols required. Beginners should connect this to the segmentation discussion, because a database that is reachable from a compromised workstation is a much easier target than a database that is reachable only from a dedicated application zone. Access control also includes identity, meaning how the database determines who is connecting, and authorization, meaning what that identity is allowed to do once connected. A common beginner misunderstanding is thinking that if the application has login controls, the database does not need strong identity controls, but the database must defend itself because attackers aim for direct access, and because applications can be compromised. Strong access control is the gate that forces attackers to overcome multiple barriers rather than walking straight into the most valuable room. Least privilege is the next concept that turns access control from a simple lock into a careful permission model. In database terms, least privilege means accounts should have only the permissions they need, like reading a particular table, executing only specific stored procedures, or writing only certain fields, rather than having broad administrative rights. Beginners should understand that many breaches become catastrophic because a single application account has permission to read and write everything. So stealing that one account becomes a master key. Separating accounts by function can reduce this risk, such as having one account for reading data and another for performing limited updates, or having separate accounts for different services rather than one shared identity used everywhere. It also means administrators should use separate administrative accounts that are not used by applications, and those admin accounts should be protected with strong controls such as multi-factor authentication, MFA, and restricted access pathways. Least privilege reduces the damage of both mistakes and compromises, because the attacker's capabilities are constrained even if they obtain a credential. When permissions are carefully designed, security becomes a series of smaller, safer compartments rather than one big all-access permission set. Configuration hardening is where many practical protections live, because databases and repositories often ship with features enabled for convenience that are not necessary for secure production use. Beginners should think of this as turning off unnecessary lights and locking unused doors in a building, because each extra feature is another surface that could be abused. Hardening can include disabling unused network services, removing sample databases, disabling risky administrative interfaces, restricting remote administration, and ensuring that only secure protocols are permitted. It also includes setting strong authentication policies, limiting password-based logins where possible, and enforcing secure session behavior. Another common risk is default settings that favor ease of connection over security, such as broad trust relationships or weak encryption settings for connections. Thorough hardening includes reviewing the configuration baseline and confirming that settings match the intended security design, not simply whatever the installer chose by default. When configuration is treated as a deliberate security decision, the repository becomes more predictable, and predictability makes it easier to defend and to monitor. Patch and vulnerability management are also central to database hardening, because databases are complex software that can have serious vulnerabilities like any other system. Beginners sometimes focus on patching operating systems and web servers while forgetting the database engine, but database vulnerabilities can enable direct compromise, data theft, or privilege escalation. Thorough hardening includes keeping the database software current, applying security updates in a controlled way, and tracking versions so you know what you are running. The challenge is that databases are often critical and sensitive to changes, so patching must be paired with careful testing and rollback planning. This is where disciplined change management becomes part of hardening, because rushed patches can cause outages, and delayed patches can leave known weaknesses exposed. A mature approach balances safety and speed by planning maintenance windows, validating backups, and ensuring monitoring is ready to detect unusual behavior after updates. When patching is routine and reliable, the repository stays aligned with known security fixes rather than drifting into outdated risk. Data protection at rest and in transit is another major layer, and it is often misunderstood by beginners as turn on encryption and you are done. Encryption helps protect confidentiality, especially if storage is stolen or if traffic is intercepted, but it does not automatically stop an attacker who has valid access to the database. Thorough hardening treats encryption as one layer among many, used to reduce risk in specific scenarios. Protecting data in transit means ensuring connections between applications and the database use secure transport settings so that credentials and data are not exposed to eavesdropping or tampering. Protecting data at rest means stored data is encrypted so that a stolen disk or unauthorized storage access is less useful. Beginners should also understand that encryption depends on key management, and key management is its own discipline, because if keys are poorly protected, encryption becomes less meaningful. Hardening, therefore, includes deciding what needs to be encrypted, ensuring encryption is configured correctly, and integrating encryption into a broader access control and monitoring strategy. When these elements are combined, encryption strengthens the repository rather than creating a false sense of safety. Logging and monitoring are essential for hardening because repositories often reveal early signals of compromise through unusual access patterns. A database should record meaningful events such as authentication attempts, privilege changes, schema changes, and access to sensitive tables or operations. Beginners should understand that logs must be protected and centralized so that an attacker cannot easily erase them after gaining access. Monitoring should look for patterns that indicate abuse, such as repeated failed logins, queries that suddenly return large volumes of data, access from unusual hosts, or administrative actions outside normal maintenance windows. At the same time, logs should be designed to avoid capturing sensitive secrets, because logging actual sensitive data can create new exposure. Thorough hardening includes tuning alerts so that they are actionable, focusing on high-impact events rather than drowning in noise. When monitoring is in place, Defenders gain the ability to detect suspicious behavior earlier, which is crucial because database compromise can progress quickly once an attacker obtains access. Hardening is stronger when it includes both prevention and detection because no prevention layer is perfect. Backup and recovery practices also belong in database hardening because availability and integrity are part of security, not separate concerns. Beginners might think backups are only about accidents, but attackers can cause data loss or corruption intentionally through ransomware or destructive actions. A thoroughly hardened repository has backups that are protected from tampering, tested for restoration, and designed to support recovery to a known good point in time. Backups also need access control because backup files often contain the same sensitive data as the live database, sometimes in less protected form if handled poorly. This means backup storage should be secured, access should be limited, and backup actions should be logged. Another important concept is immutability or protected retention, where backups cannot be easily deleted or altered by the same accounts that manage the live database. Beginners should see that recovery readiness reduces attacker leverage, because the ability to restore reduces the pressure to pay ransom or accept permanent damage. When backup discipline is strong, it supports the overall hardening goal of making the repository resilient under attack. Another often overlooked area is administrative pathways, because database administration is powerful and therefore needs extra hardening. Database administrators often require elevated permissions to manage performance, create schemas, and support operations, but that power should be exercised through controlled paths. Beginners should connect this to the earlier discussion about hardened administrative access, because if a database admin can connect from any device and any network, the repository's strongest defenses can be bypassed by a single stolen credential. Thorough hardening includes restricting administrative access to specific management networks, requiring MFA, limiting who can perform high-risk actions, and separating duties so that no single person can silently change everything without accountability. It also includes careful management of default accounts, emergency accounts, and service accounts, because these are common places where forgotten credentials linger. When administrative pathways are hardened, the repository becomes harder to take over even if an attacker compromises a general user environment. This is a critical layer because many real incidents involve credential theft rather than sophisticated exploitation. Data lifecycle and minimization are also part of hardening, because the safest sensitive data is the data you do not keep unnecessarily. Beginners should understand that repositories often accumulate data because storage is cheap and because nobody wants to decide what can be deleted. Over time, this accumulation increases risk because more data exists to be stolen, and older data may be less protected or less understood. Thorough hardening includes defining retention policies, removing data that is no longer needed, and ensuring sensitive fields are handled appropriately. It also includes controlling exports and reports, because data often leaks through reporting systems, ad hoc queries, or copied datasets used for testing. If data must be used outside production, it should be handled with strict controls and minimization, because copied data can become a shadow repository with weaker protection. When lifecycle management is deliberate, the organization reduces exposure and makes monitoring easier, because there is less unnecessary access and fewer places where sensitive data might appear. Minimization is not just a privacy principle. It is a security strategy that reduces attack payoff. To bring all of this together, hardening databases and sensitive data repositories thoroughly means building layered defenses that cover exposure, identity, permissions, configuration, monitoring, and resilience. Strong network controls and segmentation limit who can reach the repository in the first place, while least privilege and careful identity management limit what authorized connections can do. Configuration hardening and patch discipline reduce exploitable weaknesses and keep the repository aligned with secure baselines. Encryption strengthens protection for data at rest and in transit, but it works best when paired with strong access controls and careful key management. Logging, monitoring, and protected retention provide credible evidence and early detection, while backup and recovery practices protect availability and integrity under attack. When administrative pathways are hardened and data lifecycle is managed deliberately, The repository becomes harder to compromise and less rewarding to attack. In a payment environment, where the database often represents the end goal of many attacks, thorough hardening is not optional. It is the disciplined work that keeps the most valuable information protected even when other layers are under pressure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.